per day so that we can get through our chapter 3 in time. But there's one section that I really feel like we need to spend more time on, and so I feel like it'll be quicker if we just do this one, which is really fast today, and that's going to give us more time in the middle of the chapter to do one lesson only that chapter. So, and I really think you'll find this isn't too bad. Okay, basically you're going to have two things happening here. The front side is discussing one of these two and the back side is discussing the other. And all it is a little chart with some vocabulary and then lots of examples to practice, okay, on each side. So one side is talking about identifying the difference between parallel, perpendicular, and skew lines. Skew lines may be the one thing you haven't learned before, but you should know what it means to be parallel and perpendicular, and we'll review that. The next side of the paper is going to be talking about identifying the 5 kinds of angles that are formed when you have 2 lines cut by a transversal. And again, I don't know if it's in 7th grade or 8th grade, but you should have talked about those words that are on there as far as the different kinds of angles. If you didn't, we are going over it right now, so hopefully it'll make sense. And ask me if it doesn't, and I will clarify, okay? We're going to start on the side that is the parallel, perpendicular, and skew. So make sure you're on the correct side of the notes where you see the deck of cards picture. Okay, starting with parallel lines. Most of my students tell me parallel lines are lines that do not intersect. And that is correct, but there's more to it in geometry. They are not just lines that don't intersect. They also have to be coplanar. Because in just a second, we're going to talk about skew lines, and skew lines do not intersect either. So you have to understand that parallel lines have to be in the same plane and they don't intersect. Okay? Same plane, they don't intersect. Symbols, I love learning symbols because it's less words you have to write. So remember, you can use an angle symbol, congruent symbol, equal symbol. Well, here's some more symbols you can use. For parallel, you can use the 2 lines. I typically slant those because when I was taught parallel, and in my textbooks in college, they were slanted parallel lines. This book does them straight up and down. Doesn't matter, but they mean parallel. Okay, so you can use that for your parallel symbol. So for example, correct notation, if we look at the picture, would you agree that AB and EF are in the same plane and that they do not intersect? So they are parallel. So you could say AB is parallel to EF. And then notice in the picture what they use to represent that lines are parallel. They're going to use these little arrows on the lines to indicate that they are parallel. There are 2 other lines in the picture that they tell you are parallel. What lines are those? Very good. GE and HF, or FH and EG. But what do you notice about the arrows there? They use 2 to show you that they're not all 4 parallel. Okay, so these are parallel to each other, and then these are parallel to each other. So just like with tick marks, you use a different number of arrows to indicate which lines are parallel. Does that make sense? Okay, perpendicular lines. Again, we have a symbol for that. Perpendicular lines is a capital upside down T, so you can use that symbol to mean perpendicular. If 2 lines are perpendicular, what are they going to form? A 90-degree angle. So the definition is they intersect at 90-degree angles. If they're perpendicular, they're going to form 90-degree angles. So you'll be looking for the little boxes in your picture to see that they really are forming a 90-degree angle. You're going to try very hard not to assume anything about your pictures. Just because they look parallel does not mean they are parallel. Just because they look like they form a right angle doesn't mean that they do form a right angle. It could be an 89.9 degree angle, and those lines would no longer be perpendicular. So look for the markings. If they ask you on the homework to name parallel lines or name perpendicular lines, look for those markings, okay? Don't assume anything. Okay, skew lines. Has anybody ever heard of skew lines? Okay, figured this was new. So skew lines are not coplanar. They are not in the same plane, but they are not parallel, and yet they do not intersect. Okay, so I'll show you an example in a second, but get in your mind that parallel lines have to be coplanar, and they don't intersect. Skew lines are not coplanar, and they don't intersect. So for example, they tell you AB and EG are skew. Look at AB and EG. AB is back here in the back. EG is here in the front. On our two-dimensional plane, it looks like those would eventually intersect, right? But this is a three-dimensional figure. So really what that is you've got EG and in this plane, and you've got AB back here, right? Are those lines ever going to intersect in 3 dimensions? No. Are they in the same plane? No, there's no way to make a plane that includes this line and this line at the same time. So they're not coplanar, but they also don't intersect. Can you guys name some other skew lines you see in this picture besides the ones in green? AB, so the same one, but now GH. Okay, be careful, those would be parallel. Why would they be parallel? So remember, you can't just look at the planes that are in the picture. You have to ask yourself, could there be a plane that exists that would go through those two lines? And diagonally through those two lines, you could have a plane, right? That would be like going up here at the ceiling and then in the back at the floor, a diagonal plane. So those would be parallel. So how about a different two? Say it again, Karina. Okay, AB and FH, which is very similar to what they gave us with one in the front and the top. Can you guys see any other ones? Tyler? HW and AC would work. So HW and AC. Did you have a different one, Molly? Okay, perfect. So there's several more, but this is the idea. Is everybody getting skew means different planes but don't intersect, so you're three-dimensional. All right, and then parallel planes is basically the same idea as parallel lines. It's just we're talking about the entire plane now. So when you think about a three-dimensional cube here in our picture, the top plane and the bottom plane would be parallel, right? Front and the back would be parallel. Left and the right would be parallel. When you name planes, don't forget that you have to write the word plane and pick 3 points in your plane. And then this is your parallel symbol again. When you name a plane, 3 letters. Okay? So plane ABE is referring to the top plane. CDG is referring to the bottom plane. The D is typo. This should not be W. Please change that to a D. I don't know why there's a W there. Don't forget to name a plane. You use how many letters? 3. Elena, make sure your phone's put away, please. 3 letters, not 4. Just because there's 4 vertices doesn't mean you use all 4. Okay, pick 3. All right, so let's practice real quick. Oh, be careful here. Super picky notation, but when you get to the homework or the test in chapter 3, if it says to name parallel segments, make sure that you're naming segments. If it says parallel rays, make sure you're naming rays. If it says parallel lines, make sure you're naming lines with correct notation. Okay? You don't want to miss points over something simple about just your notation was off. Okay, so we'll do this one together and then you guys can try the last one and we'll check. So let's go with Karina. Can you give me a pair of parallel segments? KP and LQ, yes. So KP is parallel to LQ. Is everybody okay with that? There's lots of options, but KP is here and LQ is here, and those are marked to be parallel. All right, I need a pair of skew segments. Javi? Uh-huh. NM and KP, perfect. NM, there's not a symbol for skew, so you can just put the word and or the and symbol. NM, like, okay, either way. NM, and you said what? I'm sorry, KP? All right, perfect. Perpendicular, Alexis? Okay, we look at those and they should be, though, if this card tower's not falling down, right? But since they didn't mark it, your safer bet is to use the ones where you have the right angle markings to guarantee that they are. So NS is perpendicular to SR. And there's one tricky question on the homework where they talk about this room that is different than a normal room. And so that's the question. If I were you, I would be super careful that I'm looking for my markings. It's kind of like if you've been in those fun houses where things are distorted or the mirrors make things look weird, or if you've ever been to Silver Dollar City and been to Grandfather's Mansion and everything's kind of tilted and different. They're going to talk about a room that's different. And so in this case, I probably would have accepted your answer because that card tower can't stand up if it's not perpendicular. But on the question in the book, I wouldn't because it's not a traditional room, okay? Parallel planes, Molly? Okay, and don't forget to put the word plane in front. So plane KNM is parallel to, so we can use that parallel symbol. Plane, and you said PSR, correct? All right, and so any of the 4 letters on that plane could have been used, but only pick 3. And make sure you have the word plane or you will miss it. Notation says you have to put the word plane. Any questions? Okay, go ahead, you and your partner answer the next 4, and then we'll just shout out some answers. Okay, keep in mind that there's a lot of possible answers, okay? We're just going to shout out a few. Parallel segments. Go ahead, Sarah, what do you got? Okay, CD is parallel to BE. Somebody have something different? Go ahead, Tyler. BE is parallel to FJ would work as well. Lots of options there with parallel lines, segments. So any of the ones that were marked parallel could be listed. Skew segments. Let's go with Elena. CD and BF, very good. CD and, I was, yes, and BF. Somebody have a different one? DH and BE would work. Anybody have a different one? FJ and CG would work. Okay. How about perpendicular, Caden? Perfect. BF is perpendicular to FJ. Anybody have a different one? Okay, it's the only one marked, so to guarantee that you get the question right, I would look for the markings, okay? Again, just if it's a true box, there are lots of perpendicular segments, and so depending on the situation presented, I would accept multiple answers, but I would be careful.
Yeah. What about like crossing, like CJ?
So I don't want you to name segments that are not in the picture, okay? Only segments that are drawn in your picture. If it is asking, could it exist or are these parallel, then you have to think, could there be a line, could there be a plane? But if it's saying name it, you're only using what's drawn in the picture, okay? All right, parallel planes. Gustavo. Very good. Front and back there. So plane BEJ is parallel to plane, and did you say CDH? Okay, and that's correct. All right, any questions on the front side? Would you agree it's easy? Okay, so next page is talking about if you have two lines, they do not have to be parallel. Later in this chapter, we're going to talk about what happens if our two lines are parallel, but they don't have to be parallel today. Just two lines cut by a transversal. A transversal is our first definition we need to talk about. What is a transversal? A transversal is a line that intersects two other coplanar lines at two different points. So do you agree here that this line, which I drew over, is T? Would you agree that line T is intersecting both lines R and S at two different points? Okay, so again, R and S do not have to be parallel. If you have two lines cut by a transversal, there will be 5 different angles that are formed. And for some odd reason, this book leaves off the 5th one, and we're going to add it. So add a number 5. Okay? Anytime. There will be 8 angles formed, but 5 different kinds of angles. So if you look at the picture, do you see how there are 8 different angles? But there are only 5 different types that we're going to talk about here. Now, keep in mind there are some angles we've already learned, like vertical angles. Give me an example of vertical angles in this picture. 2 and 3 would be vertical. Another kind of angle that we've already learned are linear pairs. Somebody give me a linear pair in the picture. 1 and 2. Okay, so those are separate. Those occur all the time when just 2 lines intersect. They can intersect and form vertical angles, or they can intersect to form a linear pair of angles. But when you have 3 lines intersecting, so that you have 2 cut by a transversal, 5 different kinds of angles are also formed. Okay, so the first kind, and these are the ones I thought you should have learned before. Has anybody seen these before? Okay, so yes, but maybe you don't really remember and it's going to need a refresher. So the first one is corresponding. When I think of corresponding, I think of the same position. They have to be in the same position. So corresponding angles are going to lie on the same side of the transversal. So when you look at the transversal here, there's a left side and a right side. For them to be corresponding, they have to both be on the left or both be on the right. And they have to be on the same side of the lines, R and S. So in other words, they either have to both be above lines R and S or they have to both be below lines R and S. So for example, they give you angles 1 and 5. They are to the left of the transversal and they are both above the lines. Do you see how those are corresponding? Okay, give me, there's lots of options, so we're going to list them here. So you said 3 and 7. Those would also be corresponding. 6 and 2 would also be corresponding. And lastly, 4 and 8 would be corresponding. So you may want to list those in the box there so you can see that there are a lot of corresponding angles. Be careful. To name an angle, you must have an angle symbol. Every year on the test, I'll have students, when it says list the corresponding angles, they'll do something like this. That's not an angle. To name the angles, you have to put an angle symbol. Okay, angle 2 and angle, and it was actually 6 in the picture. Okay, so make sure you put the angle symbols when you're naming the angles. Any questions on corresponding? Okay, alternate interior basically tells you by those words, alternate and interior. Alternate interior angles are going to be angles that are on opposite, so that's the alternate, opposite sides of the transversal. So one's on the left, one's on the right. And interior means they're going to be in between the 2 lines. So notice where it says interior, that's talking about here. So 3, 4, 5, and 6 would be interior, but we want one on the left and one on the right. So They tell us 3 and 6, and Edwin said also 4 and 5. So do you see how those are alternate but interior? Okay, so I'm going to write down and angles 4 and angle 5. Okay, same idea with alternate exterior. Exterior is going to be outside the two lines, so not in between them. So 1, 2, 7, and 8, but alternate means they're on opposite sides of the transversal. So which angles are on opposite sides but exterior? Okay, they say 1 and 8, and so the other option would be 2 and 7. Okay? And then the last one up here, but we're going to add a fifth one, is same side interior. So same side interior is also called consecutive interior. Depends on what textbook you're looking in. It could be presented to you on the end of the course test as consecutive interior. It means same side interior. I like using the word same side instead of consecutive just because I think that helps me think about it as on the same side of the transversal. But consecutive means one right after the other as well. So they're on the same side of the transversal, but they're interior, so they're in between the two lines. So they say that's, for example, 3 and 5, because they're interior, but now they're on the same side of the transversal, or angles 4 and 6. So what's missing that's not up here? Same side exterior. And I, again, have no idea why the book leaves it out. I'm going to write it up here higher where you can see it a little better in the back. So same side exterior. The definition for the vocab test will be the same as same side interior, except where you see in between the lines, it will say outside the lines. Okay, so same side exterior. It's going to say the exact same thing, except it's going to say outside the lines. So you can rewrite this whole definition if you want to and then change that word to outside. Or you can just try to keep in your mind that that is on the same side outside. So pick the angles that are same side exterior here. 1 and 7. 1 and 7. Oops, I'll write it up here. Angle 1 and angle 7. And then angle 2 and angle 8. Any questions on those vocabulary words? Okay, I'm going to tell you that success in the next several sections is going to be highly dependent on your understanding of these words. You have to know these words very well and be able to pick out those angles quickly as we move on to sections 3.2, 3.3, and 3.4. Okay? Really important. All right, so let's go through. We'll just do these together to kind of speed it up. Somebody give me corresponding in this picture. 1 and 5 would be corresponding. All right, somebody different, give me alternate interior. Heard 4 and 6. Angle 4 and angle 6 would work. Somebody different, alternate exterior. 1 and 7. All right, and anybody, same side interior. 4 and 5. And let's go ahead and add a part E. I'll put it up here. Same side exterior. And Ridley said 1 and 8. Any questions on those? Okay, I want us to look at the next example because now notice that the picture shifts, and so it's not a transversal up and down, it's a transversal left and right. Okay, but still same idea. So corresponding, somebody give me a corresponding pair. 5 and 7 I heard. Angle 5 and angle 7. I also heard 1 and 3, which would be correct as well. Alternate interior. Very good. Angle 6 and angle 3. Alternate exterior. 5 and 4. And a same side interior. 2 and 3 would work. And we'll go ahead again and add E. Same side exterior. And I have heard angle 1 and angle 4. Okay, it's the next example that gets a little bit harder. Any questions before we go on to the last part? Okay, so on this next one, they're going to ask you to identify the transversal. And I did not put this in your notes, but look up here. Here is a hint. To determine which line is the transversal. So if you look at the picture and you are lost, I don't know which line's the transversal. They're all transversals. Well, the way you're going to know which one you're supposed to name for your given angle pair is to locate the line that connects the vertices of those angles. So put your pencil at one vertex, put your pencil at the other vertex, and the line that connects those 2 points will be your transversal. For example, they're giving you a specific angle pair. They want you to, part A, identify which line is the transversal for that angle pair, and then part B, classify the angle pair. Is it corresponding, alternate interior, alternate exterior, same side interior, same side exterior? So if you're not sure when you look at angles 1 and 3 about which line's the transversal, then look at angle 1, pick out its vertex. Then go to angle 3, pick out its vertex. The line that connects those 2 points is the transversal. So line L. And remember to name a line, you can say the word line and then use that little lowercase cursive L out to the side. It is not a point on your line, it's just a way to name your line. Is everybody with me that that's line L? Okay, and then what kind of angles do we have for angles 1 and 3? Notice that they are, if this is the transversal, they're on the same side of the transversal, but they're both to the left of the other 2 lines. So they're in the same position that's corresponding. So corresponding angles. Okay, let's go to the next one. What transversal is creating 2 and 6? 2 and 6 is what? Line N, as in Nellie. Line N. So angle 2, here's the vertex. Angle 6, here's the vertex. And the line that connects those 2 vertices is line N. All right, and then what kind of angles are 2 and 6? Okay, so again, if this is the transversal, they're on opposite sides, so that makes them alternate. Are they alternate interior or alternate exterior? Okay, so look at the other 2 lines that are not the transversal. Are they in between those 2 lines? Yes, they're not outside those 2 lines. That would be somewhere up here or somewhere out here. But in between those 2 lines are 2 and 6. So it's alternate interior. All right, last one. 4 and 6, what's the transversal? Line M. And again, that's because the angle at 6 and the angle at 4, their vertices are connected by that line. And then what kind of angles are 4 and 6? So if we look at 6 and look at 4, and look at these 2 lines that are not the blue one, they are outside those 2 lines, and they are on opposite sides. So alternate exterior. All right, any questions at all? Quick.